Okay, I'm going to go over number 17 from your review. We have a word problem here. It's talking about the amount of carbon-14 remaining in a living organism. And the one thing they tell us is that the half-life of carbon-14 is 5,730 years. So if I'm trying to set up an equation, now notice it says an equation that models the percentage of carbon-14 in a sample. So we're going to assume we start with 100%, all of our carbon-14. And then notice that obviously it's decaying. It tells us that the amount of carbon's decreasing. So I'm going to multiply, well, we could say 1 minus p. We're losing some percentage of the carbon every year. But what we do know is that after the half-life is 5,730 years, which means after 5,730 years have passed, in other words, once I've done this decay 5,730 times, I will be down to half of my original amount. So if I started at 100, now I'll be down to 50. So to solve the equation, I start by dividing. And notice it wouldn't matter what amount you started with. You're going to end up with half over here. 1 minus p to the 5,730 equals 50 divided by 100, which is just 0.5. So obviously now to solve for p, I need to get rid of this exponent. So remember, to do that, we take the reciprocal power on both sides. So I need to do 0.5 to the 1 over 5,730. So I'm going to go to my calculator for that. 0.5 to the power of 1 over 5,730. And I get this long decimal. So 1 minus p equals 0.99987 and so forth. And so of course to solve for p, we subtract 1. And that will give us negative p. So if I subtract 1, I get equals, and remember e to the negative 4, that just tells you how many places to move the decimal. So I'm going to use this negative 1.2, but I'm going to move the decimal back 4 places. So if I go 1, 2, 3, 4, that would be negative 0.0001296. And so obviously then positive p equals 0.0001296. Which of course tells us, remember, p was for the percentage. That means if I turn it back into a percent, that means I'm losing 0.012096% per year. Of course, that's not really what the question asks, so I didn't really have to say that. But the important part is now I can write my equation. I know that to find the total amount of carbon remaining, I start with 100%. I'm doing decaying, so 1 minus, and the percent I found was this, 0.0001296. And then I just raise that to the x power to show the number of years that have passed. Or if I want to simplify this, well, I'll just leave it like that. That's fine. So there's my equation. So now when I get to part B, where it says that we have a piece of arc that has 62.45% of its carbon-14 remaining, now we can say, okay, I started at 100%. I was losing 0.0001296 as my percentage. And then I want to know how long did it take, so x is my number of years, to get to 62.45%. And so from there I can solve dividing by 100, gives me 1 minus 0.0001296 to the x equals 0.6245. And remember, when we have an unknown exponent, we want to use a logarithm, so I'm going to do log base all of that, so 1 minus of 6245 equals x. And so in my calculator, I'm going to do log of 0.6245 divided by log of 1 minus 0.0001296, and I get x equals 3,891.99 years.